Hello world! Welcome back to this tutorial on building a Linux from scratch system. Now in the last video we've already finished our Linux system. So we've already booted it, but I had promised to make a video about the Bootscripts because they are an essential part of the boot process, and the boot process is, at least for me, the most interesting part of this whole series, and I wanted really to dissect that process in detail. So when we start the computer, the firmware will load the bootloader grub, and grub will read this grub CFG, and okay, we only have one menu entry here in which we tell grub to go to the hard drive 0 and the second partition. That's actually wrong. We've changed that to 1. And look for this file vmlinux, which is the kernel, and load that. Then it starts that kernel with these parameters where we tell the kernel which hard drive to use as root drive, and we can give it some other parameters as well. And then the kernel will just start the program sbin init. So there is that program, and when you start sbin init, then it will read the file etc init tab. And okay, down here it creates the different login sessions, but the more interesting part, at least to me, is up here, where before you get to log in, it sets up the system. It runs these boot scripts to initialize the hardware and stuff. So the default run level is 3. So if we don't give a different run level on the grub CFG, then it will execute this script here for setting up the hardware. Okay, so it runs this script here, and it's not that complicated. What it basically does is it loops here and goes through the files in etc rc3, for example, if 3 is the run level, .d. And in that directory, all the scripts that start with a K are being started with the parameter stop. Where is it? Here. Run the script with parameter stop. And a bit further down, another loop through the scripts in etcrcd, rc3d, and then it takes all the scripts that start with an S and starts them with the parameter start. Okay, and everything else is just stuff that, for example, prevents you from starting a service that is already running and stuff like that. But this is a core thing that happens. So okay, in rc3.d there isn't much in here. We only have this klogd and network. That's because most of the scripts are actually in rcsd. And yeah, the scripts in there, they are for all run levels. So yeah, let's go through these scripts and see what they do. Okay, the first thing that will be run, that's determined by this number here. So the first thing that will be run is the script number 0, which is mount_virt fs. So let's look into that script. And yeah, most of these scripts will just look at their parameter. Their parameter will usually be start or stop. Then depending on start or stop, they will do different things. And the mount_virt fs basically mounts the proc, sys, and dev directory. Also the shared memory, run directory. So these things that we've also seen in the video about the change root environment. Okay, next thing that will be run is modules. Now modules, when you start that script, what it mainly does is this loop here, where it mod probes the modules that it found in etc/sysconfig modules. If you've seen my video about kernel modules, I've said that in system V you can change the location from where the init system will take its list of modules, and yeah, this is where you could change that if you wanted. So some distributions would just have etc modules or etc_rc modules or stuff like that. So but okay, that's the modules. It goes through this list and mod probes the modules in there. Okay, localnet. Localnet, yeah, basically just assigns the IP address 127.0.0.1 to itself. Okay. It also sets its host name, which it takes from the file etc hostname. Also not very difficult here. Okay. udev starts udevd and then tells udev to create the dev directory entries for the devices that are already discovered, and everything else will be then added by hot plug events. So if the kernel discovers more devices after that, udev hooks into the system of the discovery and will then create the dev directory entries from that hot plug event. Okay, swap. This is a very simple script. When you start it, it runs swap on. When you stop it, it runs swap off. Restart will run itself with stop and then with start again. That's relatively standard script. Check fs. It runs a file system check. Now mount fs already tells you what it does. It runs mount and mount all. Yeah, that just says go to the etc file system table, etc fs tab, and mount everything in there. And when you stop it, it unmounts everything. So that's not surprising. Clean fs, yeah, does a bit of tidying up. So for example, it deletes everything it finds in the temp directory. I think it also checks the access rights for a few directories. Nothing fancy. udev retry. Yeah, runs udev another time because yeah, the discovery of the devices might have some trouble. For example, if they need something from the root directory, from the root drive, and the root drive might not have been mounted at that point. You know, you might only have mounted the initial RAM drive, and after udev you do the mount fs, which mounts the root directory again, and at that point it could switch from the initial RAM drive to the actual hard drive, and yeah, now you might have some additional drivers, stuff like that. So that's why the discovery of some devices might have failed before. Okay, then the console. That's also something that we did explicitly. The script runs load keys, so it loads the key map and it sets the font for the console. That's stuff that we've also done manually. Syscontrol basically just runs syscontrol q and p, and that will load the file etc syscontrol.conf, but we haven't even created that. If we had one, it would be for making some changes to the proc file system. Yeah, you can look into the man page for that. Then we have this klogd, which is a daemon that yeah, receives yeah, the system log. Not surprisingly, if you look at the name of the script. So that starts the syslogd daemon and also sbin klogd daemon. And the last thing that we start for run level 3 is network, which will iterate through the configurations for network devices in etc sysconfig interface config .eth0, for example. And then it will just call sbin interface up with that interface name. Or if you stop the script, it will run sbin interface down with that interface and unmount everything that might. That's actually not such a good idea to unmount everything that uses network file systems, because you can have multiple network interfaces, and you could have mounted some network resource that you access through a different network interface that might not be controlled by this script. So that's actually not such a good idea, if you ask me. Okay, then there is also the script set clock. This would basically run hardware clock to configure the clock. Interestingly enough, it seems like this script is never run, at least in the default configuration for Linux from scratch. So, but okay, the script is still there. If you want to, you can enable that. And then we already come to the scripts halt, send signals, and reboot. These are a bit special scripts because they work a bit differently. Because they can be started, but they just don't do anything when they are started. They are only supposed to be run in run level 0 or run level 6. So here you would have halt or the reboot script, and well, for run level 0 and 6, although they have an S here, when you go to run level 0 or 6, nothing is started. Everything is called with stop. So when you go to run level 0 or 6, these scripts will be called with parameter stop, and well, the halt script will then turn the computer off. The reboot script would reboot the computer, and the send signals script runs kill all. And yeah, once only with parameter 15, which is the term signal. So it asks all the running processes, please terminate gracefully, and those that don't obey, it waits for a while, and the processes that are then still running, so they haven't obeyed to the polite request to please terminate yourself, well, they are then terminated in an ungraceful way. They are just thrown out of the system, and then that's that. And that's all the scripts there are. So I think we now have a really good understanding of what is going on in the boot process. And yeah, that's all I wanted to do in this video. So if you liked this video, like it, share it, subscribe, and see you next time.